chemical kinetics. First of all, we have a question. What is the definition of the chemical kinetics? Mainly, this chemical kinetics uh, mainly deals with number one, rate of reaction. So you can say the chemical kinetics is a branch of the physical chemistry which deals with number one, rate of reaction. Number two, pathway of reaction, or you can say mechanism of reaction, or you can say uh, uh, steps used in a reaction, or steps followed by reaction. Third point, you can say it also deals with energy change involved in a reaction. Energy change involved in a reaction. So you can say the chemical kinetics deals with these three kind of work. One, rate of reaction, the mechanism of the reaction, you can say path of the reaction, uh, or the steps involved or followed by the reaction, and thirdly, the energy changer. After this, types of chemical reactions uh, in this chapter chemical kinetics, I am not telling you what are the various type of chemical reactions, just by the eyes of the chemical kinetics. So types are of reactions which is required to study the chemical kinetics. In chemical kinetics, here I will write CK, chemical kinetics. There are two reactions, two types of reactions. One is reactions, elementary reactions, and second is complex reactions. So elementary and the complex reactions. Here I am writing elementary reactions, here complex reactions. The elementary reactions, there is only one step involved in this reaction, elementary or simple reaction. Elementary reaction, we can say it is also called a simple reaction, or we can say it is one step reaction. Here in this we can say number of steps are involved, more than one steps are involved, more than one steps are involved. So we can say here to this uh, multiple step reactions. So the complex is multiple step reaction. Here we are taking example. Suppose that here we have 2NO plus O2 and producing 2NO2. Now this is the reaction. Here we can say first step of reaction, step 1. What happens? 2NO changes first into the N2O2, and after this in the step number 2, N2O2 reacts with O2 and gives 2NO2. There are two steps involved in this reaction. We can say these two steps are the just part of this reaction. It means this is the first step of this, and then this is second step of this. So the multiple step reaction is complex reaction. Here we can say the example, any one step. Suppose that 2NO, it is N2O2. This is simple reaction or elementary reaction. Here, this is one example, example number 1, and the another example we can write here, N2O2 plus 2O2 plus O2 producing 2NO2. This is also elementary reaction. So or the simple reaction. So we can say the steps of the complex reaction are the elementary reactions. We can say this too. Now we have to little draw the graph by which they complete here. So I'm writing step number point number 2 here is the progress of reaction. Here is the progress of the reaction, and here is energy. Here is reactant, and here is the peak value of the energy, and here suppose we have product. So this is the graph. This is the graph. Here in this peak, this is one step reaction, and here in this case we can draw the same graph. Here we are telling progress. Here is energy. Here is progress. Here is reactant R. This is one step, and this is the another step. This is first step, and this one is the second step. Don't worry, we will discuss these graphs in detail in this chapter under the collision theory of reaction. So don't worry about this graph. Just it is for the just giving you the introduction of the complex and simple or elementary reaction. Since this is the one step reaction, that's why we can say this is the graph of the elementary reaction or simple reaction. Here in this case, there are two steps, one step and another step. Since two steps are involved, so we can say due to these two steps, it is the graph of complex reaction. So friends, what we can conclude? We can conclude when we look the reactions by the eyes of the chemical kinetics, then they are of two types, elementary and the complex reaction. The elementary reaction is that which complete in one step. This is single step reaction. The complex is that which complete in more than two steps. That's why it is also called a multiple step reaction. We will discuss, just this is just introduction, we will discuss later to this. Now dear friends, after this we have to study little about the rate. We can say we have to study the rate of the reaction. Rate of reaction. What is rate of reaction? Rate is equal to change in amount upon time taken. Here we can say this is the rate. Here I wrote amount. So amount that may be mole. When we take amount is equal to mole, then we can say rate is equal to change in number of moles upon time taken. After this we can say if volume of container is constant, only then amount is equal to mole per liter. So we can say rate is equal to change in number of moles divided by volume of container, and what was here? Here it was time interval or time taken. Here I wrote change in number of moles, but here I wrote clearly volume of container, because here volume of the container that is not changing, that is fixed. The volume of container is not changing, it is fixed, it is constant. So we can express the rate in terms of the mole. Here we can write the unit of rate. Here we can write unit of rate. Unit of rate, it is equal to mole upon unit of time. So we can say here mole per second, or we can say mole per minute, or we can say mole per hour. So these are the units of rate: mole per second, mole per minute, mole per hour, or we can say mole per year. So these may be the units of the rate when we take when we express the amount in terms of mole. Here we can say unit of rate, it is equal to mole per liter, and unit of time, so it may be mole per liter per second. So this is the unit of the rate when we when the volume of the container is constant during the reaction. When volume of container is constant during the reaction. The third point is for gaseous reaction. For gaseous reaction, we can say here for the gaseous reaction, rate is equal to change in pressure upon time. And here, dear friends, we can say the unit of rate, this is equal to unit of pressure upon unit of time. So atmosphere per second, or you can say bar per second, or you can say Pascal per second, etc., etc. It's well known to you. The fourth point here, just I want to give you little here in this here in this mole per liter per second we wrote, but same time we can also say in this section unit of rate, this may be equal to mole per liter per hour, or we can say mole per liter per year, or we can say mole per liter per minute. So you know, we can express the volume in terms of the liter, so mole per liter per minute per second, etc., etc. Here in this case we know that mole per liter, it is also expressed as m. Mole per liter is also expressed as m. Here the fourth point, which is very important, we can express the it is not in usual practice, it is not usual, but it may be, it may be, it is possible, but it is not usual, but it is possible. Even we can express the amount in terms of mass. So we can say change in mass divided by time. This is also the rate. So I told you this is not usual, but this is possible. So change in mass upon time, it is also a rate. So dear friends, what we explained here in this case, we did a little about the definition of the chemical kinetics, and then the types of reactions by the eyes of the chemical kinetics, and the simply the how we can express the rate of the reaction